The phone had problem. Hello, can you hear my voice now? Oh, okay. And then sometimes we have some little problem. Okay, so that yesterday I had some video conference with the Hong Kong U like a medical doctor, so that it's clear that COVID-19, this kind of mutant virus was continuous spread. So that I'm sorry that we Hong Kong we're going to have a lot more people get this kind of Omicron virus. So that I hope that all of you first try to make sure you have a good exercise. Even at home you can do exercise, and also make sure that you everything you I think this is something, unfortunately we are in a very difficult situation. So that that's why I still want to remind you, make sure that you follow this kind of typical advice. Now make sure you are healthy, right? So that it's a great, make sure that you in the public area you try to use a face mask, and also wash your hand, and social distance. So this is something important for all of you, right? And so of course please also try to look at the possibility to beyond this kind of basic protection, right? To in this COVID-19 pandemic, so that if possible, I told you, I also bought this kind of portable antivirus, this kind of air purifier, for my office and things. So anyway, so that of course there are multiple this kind of a product you can buy, but at least I invite this kind of guest speaker, Mr. Ayong Yi, the company give a very good summary about different kind of this kind of air purifier, and also disinfection system. So that that's something I just let you know that we are in a difficult situation. So do you have any question about COVID-19 problem? Hello, any question? Any question about the problem? Oh, I can see in the near future we have a lot more people in Hong Kong will get this virus. This exponential increase, and there's something there's no, unfortunately. Of course, I do provide you some additional reference if possible. You have time, at least you look at some. Oh, I also got some ebook I bought from Amazon.com, so that for you to have some idea about possible this kind of, once you or your family member got this kind of COVID-19 virus, so that at this moment, if you go to Hong Kong public hospital, unfortunately, I don't think the Hong Kong the government allow you use this kind of special this medicine, ivermectin. So this is some interesting like medicine to kill those kind of worm, for both for animal and for human. Actually, there's two. One professor in Japan, and also one researcher in United States got the Nobel Prize in 2015 because of the invention of this drug. So that this can give you some reference, right? So that do you know what so at least according to the ebook, this may be a cheap and proven and safe drug to treat this kind of COVID-19. Okay, so that I said let you know this thing, but do you know what's the problem? What's the problem of this job? Anyone? The problem of this job is so cheap. So actually, those big pharmaceutical company, they are spend $1 billion to develop some kind of new COVID-19 drug, so that actually some big company try to prevent this kind of drug, local drug, to be used in some of these kind of developed country. Only those kind of countries like India, Egypt, some country in middle Africa, maybe in Africa and maybe America, mid South American, they try to use this kind of drug. Actually, I do contact one of my UC PhD classmate friend, is a professor in India, so that my friend in India actually got this infection 10 days ago. So that's anyway, I just tell you that unfortunately, this may be a good possible drug, but even the inventor of this kind of ivermectin, Professor Satoshi Omura, actually he made a speech now on YouTube, and then show this is this kind of drug may be useful for COVID-19. Actually, his video actually was removed by YouTube. It's censored. So you can see those are big pharmaceutical company. It's very powerful. In order to make money, they don't care about human life, so that they don't making money is the first priority. So that's why even this Professor Satoshi Omura's talk on YouTube was removed. So that I just tell you, unfortunately, there's something COVID-19 make a big problem, and then even this kind of drug can save people's life was also a but I just let me know that unfortunately this is something in Hong Kong we're going to see a lot more people got this kind of COVID-19 virus. So do you have any question? Here I just provide you some information beyond our course, but unfortunately this is one of the issue. Right? We're going to have more people die due to this kind of virus infection. So so that this is a quite important serious issues. I want to say, of course, I just show you there's for example, I also bought this kind of plasma air purifier now for my home, and then so that it just give you some additional reference. Make sure that you have some additional understanding about how to protect yourself. Okay, do you have any question? Any question you want to ask? One student shown Ho. Unfortunately, COVID-19 make a big problem for everybody in the world, and some good solution because some big pharmaceutical company want to make money. Making money is first priority, so that they don't want some low cost drug to be widely used, including I think according to Hong Kong government, they don't let this kind of medicine to be used in Hong Kong public hospital. Unfortunately, I just tell you, even FDA, my second PhD student have been working for US FDA for more than 10 years. I also asked the same question. Of course, he cannot, there's a FDA have the same policy, uniform policy. He just show the official announcement from FDA, so that this particular drug, they only say, oh, FDA show, oh, this drug can be used for animal. I told you, this is unfortunately, capitalism, those big company is too rich. They really want to make money. They don't care about humans' life. Unfortunately, even US FDA, they don't allow this particular one to be used. But they still have some good medical doctor in United States, in other country. They think this should be useful, including some hospital America in Japan. And actually, I also read a series of paper about this kind of clinical study about ivermectin. So that anyway, so I tell you that unfortunately, this is something making money is good, but somehow those kind of super big company, they are too powerful. They try to prevent if something they can they start to making the money for then they will try to restrict this thing. So that unfortunately, I just tell you, this is something I just want you give you a real truth about this thing. So that if even let me just show you this particular website from FDA, so that they think ivermectin can be only used for animal for animal only, but there's a large number of medical research paper about this thing. It shows it can be at least effective to this kind of clinical study. So that so this is I just tell you know that this is something unfortunately you need to understand. So that I provide you the most updated information I collect from multiple channel, from medical paper and some of this even ebook I share with you, so that I hopefully you understand the real truth. There's so many information on the they call the misinformation, but I try to provide something I think it should be useful for you to and your family member and to protect yourself. So that again, to do any question about this thing, so that I think this is something you I hope that this information can be useful. Okay, yeah. Again, so that I also again share with you this ebook I bought from this Amazon.com, so that if your time it's not very it's only 10 pages, but I think it will be interesting and useful for you to study, understand about the real truth of this medicine, and why those big pharmaceutical companies don't want this kind of drug, ivermectin, to be widely used in hospital, in many even in United States, and same even one patient in United States, they request the medical doctor to, oh, I want to use drug, and the medical doctor in United States, they don't want to prescribe this medicine, and then the patient, what the American, they sue, they find a lawyer now to say, okay, if you don't give me the job, I should find a lawyer to sue this medical doctor. I told you this is something, unfortunately, even in Hong Kong, if you go to the Hong Kong public hospital, unfortunately, I don't think they'll provide you this kind of job to for this kind of COVID-19 infection. This is something I tell you is quite a serious, big, very, very bad from my point of view. Okay, but anyway, keep you healthy, right? So it's a more important thing, right? If you do more exercise to increase your immune system, so that that's something important. And then try to wash your hand, and also make sure that you wear this kind of face mask, right? And social distance, so that the government of Hong Kong also try to have most restriction. Only 2 people can have a dinner or a lunch together, so that's something. Social distance is another important thing. Yeah. Again, do you have any question? If not, then I just provide this information now for you to make sure that you can survive in this COVID-19 pandemic. That's something is, unfortunately, this is one of biggest problem. We have suffered this kind of problem for more than 1 year. Okay, so that if now I think we can actually go back to our lecture. So last time we talk about this kind of urban living, right? And then so that I think there's one student asked about this kind of issue about urban sprawl, right? So that let's quickly, I think we try to show you there's one spatial name, so that one student asked about urban sprawl, right? So basically, this is very common. So the reason is just like Hong Kong, right? So that when this kind of we have a more developed kind of city, and then the housing price become more expensive, right? And then what happened? Housing price become more expensive, and then if you cannot afford, if you cannot afford this kind of expensive the housing price, and then what should you do? Huh? And then in this case, you may need to think about try to maybe find a apartment, a house near the maybe urban area or suburban area, right? Some people may, I understand that we do have some people, Hong Kong people live in Shenzhen and then commute, no, every day, right? So of course, COVID-19 prevent this kind of thing, right? We do have some student living in Shenzhen and then come to Hong Kong to study. So that's something is very common. Okay, so that this is something. Of course, I should try to show you that if I provide you some this definition of what is this kind of this is an urban sprawl. I want student ask a question. And basically, urban sprawl is just defined as a spreading of this kind of development of this urban development, right? So if we have those kind of building, apartment, in maybe in the downtown area, it's so expensive, and gradually people will move, right, to those kind of undeveloped land near city. For example, Shenzhen is a little bit cheaper, so that of course the typical thing is not only in Hong Kong, right? Many big cities have similar thing like Japan, Tokyo, right? And also Los Angeles. Actually, I more than 25 years ago, I studied my PhD at UCLA, so that Los Angeles is one of typical example of the urban sprawl, right? So of course, I give you some additional reference for you to understand this kind of a phenomena, right? So that this is something quite common, right? Some of a big country, if economic continue to grow, and then attract a lot more people from countryside to make money, right? Have more opportunity in big cities. So that is very common. Okay, so that of course in Hong Kong we have the high-speed train, right? If there's no COVID-19, I believe some of you may be able to live in a little bit cheaper this kind of apartment, a house, right? Near this kind of big Bay Area, and then you take this kind of high-speed train, right, to commute every day. If it is no COVID-19, I think it's possible, right? So that I still remember, like if you take a high-speed train from Hong Kong, this high-speed station to the Shenzhen, Futian, or no, Shenzhen North station, right? Of high-speed Shenzhen is about only 20. I think going to Futian is also probably 14-15 minutes, right? It's very, very fast, I think. And so that's something, but the price of housing will be much cheaper. I understand that's something is a thing, right? So that of course, this kind of urban do have problem, right? So as we'll in the first part of this our lecture, we also mention about this kind of 同房, right? So cubicle, right? This is something unfortunately, and then we do have even long time ago we have this kind of a tanka people. If people cannot afford this apartment on the land, this kind of apartment, then maybe living a little boat, right? So that actually one of super rich for Indong. Actually, people say when he was young, and then so that he should living, he's like time cup people. Okay, so that that's something is unfortunately we still have some probably people still, if they cannot afford, they have to live somewhere, right? And so that of course actually in recent year, even in Hong Kong and in some maybe big city, so that there's another way, right? Beyond living the this kind of cubicle and tanka. So do you know there's any other way people can find some temporary like a place to live? Any idea? Unfortunately, Hong Kong, some people, poor people, they're living in McDonald's. I don't know if you have seen some news. So that that's real truth. So that I just show you one article from our local news article, right? So that we do have people, unfortunately, some people live if that cannot afford living in this kind of a typical apartment, they have to live in this kind of a home is so expensive. There's some people, very poor people, they live in McDonald's. There's some special name, Mac refugee, and so that unfortunately, even in Hong Kong, we have this kind of issue. I also see this is not common. It's not only happen in Hong Kong. In other big city, like Japan, actually they also have seen. Let me quickly show you this kind of thing. Unfortunately, it happened in Hong Kong.
喂，我啲汽水終於飲晒啦喎！嗰樽汽水飲咗4日。咁快快，都有人喺呢度。飲咗4日啦。即嗰啲職工佢講噶嘛，同我哋。仲包咗㗎。佢話：喂，你要揾定地方咯喎，今晚呢度唔俾坐喎嚇。我話唔俾咪走咯，我話。佢話唔俾過夜喎。幾點啊？佢6點清場喎。6點瞓晒走晒。可以買外賣，人坐咗喺呢度。我叫黃燕雅，今年啊叫做81歲，由舊年7月7號開始就離開屋企，就響出邊瞓。有時呢間麥當勞或者嗰間麥當勞都唔定。大家都知道呢度唔係自己屋企，只不過借人地方落腳啫嘛。人哋俾你響度就人情，唔俾你響度係應該嘅，因為呢度人家先係正式嘅主人。走啦，走得，走人咪走人，走人。做賊都要做得高明啲，冇啲人話響度食響做乜。走咯，拜拜。睇住。由舊年7月7號，我去放狗返屋企，間屋就俾人搞到亂晒，咁啊報警，差館就話佢呢啲唔係叫打劫喎，叫屋內失竊啫喎。你點下失咗啲嘢人先報啦咁。我心嚟話點啊，間屋亂到都入唔到去。咁既然佢咁講，報過2次都咁。算啦，仔女又唔翻嚟幫我執嘢，心灰意冷啦嚇。除咗換衫、洗頭會翻下去，係冇翻嘅。哇！我個位俾人用咗，咁惡死！佢依度咧，好在咩咧？落雨，啲雨撇唔到埋，唔撇得咁盡噶嘛。曬又曬唔到裏邊噶嘛。咁呢邊又通風。如果講涼咧，隔離嗰個位仲涼過呢個位，不過咧隔離嗰個位咧就夜晚靜啲， 咁我就唔制啦。呢度咧多人行啲嘛，後邊啊人靜嘅地方好危險㗎。政府俾嘅咪要，你叫我攤大手問佢攞，我唔落得面，唔落得面。食積蓄咯，維持得幾耐得幾耐㗎咋。我冇咩負累政府，我只不過最唔啱嘅就係黐麥當勞嘅地方，就係呢樣啦。上次山日頭啊茶樓過啦，夜晚咧同人傾下偈啊，攰啊咪挨喺公廁度瞓一陣咯。我冇所謂㗎，我後生成日做嘢做股務，去到嗰度就瞓到嗰度，冇感覺嘅。催淚彈我都睇人放啦，有咩好驚啊？我膽生毛㗎嘛，最驚對人唔住啫。
Okay, so this is to give you some real truths, right? Even in Hong Kong, we do have some people they suffer. They cannot even afford this kind of cheap apartment to live. So that that's something that's a real truth. So that what do you think? Huh? So I do think that the Hong Kong government do have enough money so that they should be able to provide this kind of public housing for for this kind of old people. In this video, right, it's more than 80 years old lady, and then even she cannot have this kind of live improperly, and they have to live in the McDonald's. So this is something personally I don't think the Hong Kong government should be responsible, right? So for this kind of poor people, that's something I just tell you. This is a real sad story. On the other hand, so that it's a real truth that all of you need to think about how you are going to choose your plan for your future, so that don't just spend a lot of time on social media, and then you do need to make sure that you learn this kind of a good knowledge and skill, so that when you graduate, and then you can really make a good money, and so that otherwise you suffer, right? If you don't have a good knowledge and skill, then you may suffer this kind of thing in the near future. Cannot afford to buy or get this kind of rent apartment and living in really good this kind of condition. So that's is a real truth, unfortunately. So that so I don't know. Do you have any comment for this issue? So that unfortunately Hong Kong has one still Ming Ho say they need social worker. Of course, in Hong Kong we our birth rate keep decreasing, so that we're going to reach this kind of aging society. So I think in several years, we have probably 20% of Hong Kong people is more than 60 years old. So that is something is a big serious thing. Why I remember there's one statistical data to show why, so that in following maybe 3 or 4 years, with Hong Kong we're going to reach kind of aging society. That means about 20% of Hong Kong people will be actually they're actually more than bigger than 60 years old now in I think several years. Okay, so that so that this has become, we're going to have aging society. So that how to deal with this kind of aging society, I think is a big issue. Okay, so that this is that means when you graduate, maybe you need to maybe the government will increase a little bit more tax. You make money and have to now government the tax will be paid for this kind of social welfare, right? So that's something old people, of course, maybe the government will try to increase, right? The age to maybe 65, 70 years old, then you can retire. So that's something Hong Kong going to have this kind of aging society, very similar to I think probably the situation of Japan. So that we're going to reach this kind of issue. So I just tell you this is something is unfortunately Hong Kong, like many young people will not get married and also have no kids, so that we are aging society. Okay. Anyway, so that of course in the past 7 years, gradually Hong Kong still have some urban this renewal project. So that this is just one example. So that in Kwun Tong, actually some region is very old and all the building is too old. So that the government, of course, try to have some this kind of urban renewal. So this is a show thing, and then I think eventually this one I think that they should almost finish this kind of try to reorganize and rebuild this kind of this area, right? So that in general, of course, so there's some general policy, right? How this kind of government set this kind of policy to have this kind of good building and the building a cluster building, right, for this thing. So that this is to give you some basic guideline from the I think typical those government policy that it is that makes some reasonable this kind of standard for typical apartment, right? So that of course unfortunately I just show you in the first slide, on the first slide, so that the typical the average this kind of area of Hong Kong people can share in the apartment in Hong Kong is very, very small compared with many other countries and regions. So that that's unfortunately because the housing price is so expensive. Yeah. Okay. Anyway, so that of course once you have a big cities, and then of course we must have some reasonable good transportation. In general, Hong Kong do have a very convenient this kind of public transportation system, MTR, subway system, and also this kind of a big bus, double deck bus and mini bus, right? Those mini bus come to USD is 24-hour operation. So Hong Kong do have a good kind of public transportation system, and compared with many other big cities like Hong Kong and Japan and like Beijing, Shanghai, so that you can see most likely now if you reach this kind of 7, 5 million, 10 million, 20 million people, then most likely it's important to have this kind of good subway system or some train, right? Express train or things to make sure that you can really have enough capacity to move, right? Do in one day operation. Okay. Anyway, so that I just gave you this is something typically nowadays. So that I think many government they not only care about economics growth of a city, also try to make sure you have a good environmental friendly design for the building and the city planning. So that's something. That's why Hong Kong government do have this kind of green building idea, green building, and also smart building, and also what like zero carbon emission. So that gradually that's another carbon neutralization is another important topic globally, right? So that how we can have a building which can close to energy efficient building or zero carbon this kind of emission, so that or carbon neutral this kind of design. I think it's become big issue, right? So that definitely I think if we can have a good smart building or green building with a lot more sensor and AI, and then also use some of the smart material, smart window. So definitely it's possible we can have reached kind of a good design to have a smart building and smart city, right? So that's something is quite important. Of course, I will try to find maybe some guest speaker to think about about this kind of, for example, AI or the kind of smart building or building automation, right? To think about how we can become much better this kind of smart city, right? Or smart building and save energy and then much more. I think this is okay. Well, we almost finished this lecture, so I don't know. Do you have any question? Do you have any question? One student make a comment. Hoi Wat Kyung mentioned that the Kwun Tong urban renewal phase 1, 2, 3 have done, and then phase 4 is in construction. Okay, thank you. This student has very good information for all of you. So maybe he has some relationship, maybe living this area, so he know much more. Okay, so thank you for this student Hoi Wat, and they have provided this kind of information. Okay, and any other question or comment for this lecture? Any other question? If not, I think we should. Another student as Paul Yan Lee mentioned, dispersed city prefer travel by automobile. What do you think? This question is quite important actually. Why once you have this kind of like urban sprawl, right? Spread in this kind of big city is not only limited to a thing, and then we spread to very large area in big city, right? So then in this case, of course, people may travel by automobile, right? You drive car, or you maybe take some buses or subway, MTR, so that so of course in general we can see I think many big cities now they gradually try to think about what, how to minimize this kind of conventional, this kind of a car, right? And turn this kind of conventional car had to burn this kind of a gasoline, right? The oil, and then we create a lot this kind of air pollution, and also this kind of CO2. So it's not good for our Earth, right? So that's why we're global warming. So that many country and region we come to this kind of electric car, right? So that's why at least several years ago, I know the Hong Kong government have provide some money to incentive. If you can buy some new kind of electric car like Tesla, and then you have reduced some tax, so that provide this incentive to use this kind of e-car, electric car, so that in this case you can minimize this kind of air pollution and minimize CO2 emission. So this is something I think is a general trend. So of course, some people say electric car may have caused some problem, pollution as well. But there's many other way, right, to power this thing. Yeah. Oh, one student mentioned, White Chain also mentioned they cancel this kind of policy. I understand. So that I understand. So that at least they is the one period of time they want to push this kind of more electric car, and then provide some tax reduction. But of course, but at least I can see that electric car for Hong Kong should be good, because Hong Kong have very small this kind of area, right? So that I think if you can charge those kind of battery, and then so Tesla, this kind of car should be good enough, right? Some big city, maybe it travel from east to west, it take maybe 2 hours, or it's longer, then it's not very convenient, right? But for Hong Kong, I do believe that the electric car should be good, right? Of course, the different way provide this kind of don't use this kind of engine, traditional engine. Use maybe I think Japan use what, hydrogen. Do you say like Tokyo? I think there's one big company, right? They try to use this kind of hydrogen to power the car. So in this case, probably a little bit better than those kind of the car powered by battery. So that hydrogen, I don't know. I think this is another hydrogen power the car. Is another thing, probably more environmental friendly technology. So that I do think this like Toyota do have this kind of hydrogen. If you burn the hydrogen, so that what happened? So that it turned in, it'll be much more environmental friendly. But of course, in the past, this kind of technology has still not mature. Why? Think about if you store this kind of hydrogen, what's the issue? Huh? It can be dangerous. Why? Safety is very good. Once you so that you do need to have very good design and very good material, right, to make this kind of hydrogen-based car. I think Toyota actually have been doing this kind of hydrogen car for a long time. So gradually, I can see this kind of hydrogen car should be a little bit much better than those cars powered by battery. Right? Battery eventually you have minimized this kind of lifetime, so that I can see that if this kind of technology become much more mature, I do think this kind of hydrogen-based powered this kind of car will be much better for this kind of to deal with this kind of global warming issue. So this is something I do think it's important for all of you to think about this issue. Right? So anyway, so that okay, I think we around I think finish this part. So that if do you have other question? If not, then we should go to the next lecture about. So next lecture is building system. So that let me try to one student also make comment about hydrogen power car. Well, you're right. So that any kind of new, right? New car with different kind of energy, then you do need to think about how to build this kind of infrastructure, right? We use this kind of engine, traditional engine, to power this kind of a car for almost 100 years. So that this kind of a gas station is exists for about 100 years, right? So that once you use like a electric car or hydrogen power car, then in case there's issue, right? How you build this kind of infrastructure, right, to provide this kind of way to make sure refill this kind of even the I think this is in general, all the new technology, it takes time to become more and more mature, right? So that I think that the student Xiong Hin Ho actually make a good comment. And but of course, you know that in Hong Kong, every taxi in Hong Kong is a Toyota. It's not a gasoline. Do you understand? LPG. Huh? So that every gas station in Hong Kong, they do provide LPG. Huh? This kind of thing for Hong Kong taxi. So I think it should be not very difficult to think about this kind of thing, to change a little bit, right, about the typical gas station, so that you have both. I guess it should have both. You still provide typical gasoline for traditional engine, a car with engine, and then with the electricity, right? Like a charge this kind of thing for the like e-car, like Tesla, and also the hydrogen. I think in the future, I guess probably we can think about this kind of hybrid, this kind of the hybrid, this kind of a gas station, so that gradually have a transition. I don't think we can every city can quickly get rid of all this kind of car and replaced by a new car. It all take time. Yeah. Well, one student also mentioned why all the taxi in Hong Kong that use LPG. so that that's incentive, right? So that because I guess this kind of LPG based taxi they have a little bit cheaper, right? For that for taxi driver to survive, I do say. So that you have seen if you use typical those gasoline is quite expensive, right? So that I don't know. Do you know how expensive is no the price, the oil price in Hong Kong? Huh? How expensive? Of course, I guess if you probably don't have car or your parent have car, so you see when we buy $1 Hong Kong dollar this kind of oil, and then we pay $1 like tax. Do you say it's of course Hong Kong government do do want to impose this kind of high tax so that encourage a lot more people in Hong Kong to use this kind of public transportation system. So $1 oil and $1 tax. That's typical thing. I still remember 10 years ago, I went to we have some joint research project with Saudi Arabia. Wow, the oil price in Saudi Arabia is much cheaper. So that I see there's a so big difference. So that it's of course Hong Kong the government they do want to encourage a lot more people to take the public transportation system, and then so that think about if everybody have a car in Hong Kong, what happened? We're going to have a big traffic jam. So that that's unfortunately is a big issue, right? So that's why you see I don't believe everybody can have car in Hong Kong. So that's something that is a real deal. Of course, to have a car in Hong Kong, you have a every year you have paid this kind of license fee, right? Also very expensive. Like I pay more than 5,000, 6,000 Hong Kong dollar per year. Oh, now it's keep increasing, right? Like in United States, I still pay license fee every year in United States much cheaper, like $100 US, about 800 Hong Kong dollar. So that this is a very different thing, right? As Hong Kong very small, so that's something very different, I would say. Okay, I think we already finished this kind of lecture, so we should go to this another new chapter. So this next chapter it talk about the building system. We in the first chapter we talk introduction, right? Overall about building engineering and then urban living. This one is a building system in general. Building engineering. Engineering need to think about the building as a system, right? Engineering, so that we need to think about the building has different. First is the most important thing is we think about how to build this kind of mechanical structure, right? The building, the first thing is you need to think about mechanical structure design, right? So the structure system design into the foundation, building envelope, and also the ceiling and floor. So this is first thing. Now we need to think about here, right? So that and then this is more on mechanical engineering aspect and water system, HVAC, heating, ventilation, and cooling. Right? In these 2 days, like yesterday, where Hong Kong is so cold, right? It's 6 degrees to 7 degrees, right? So unfortunately, Hong Kong we don't have this kind of heating system, right? For northern part of China or Russia, most likely in winter, a city will provide this kind of warm air, right? For thing, but unfortunately, Hong Kong we don't have this kind of thing, right? 6 degrees in Hong Kong is pretty low, I say, right? So that and then we have electricity and lighting system, fire protection, elevator. Of course, what's new? Beyond this one, of course, I can see all typical modern building in Hong Kong, we have additional ICT. Why? Most likely, we have a Wi-Fi, we have probably have this kind of IoT, wire communication, right? LoRa, right? And also 5G. So that I can see, so that actually we should try to think about take a new building, right? So they have additional ICT, so that you need to add additional this kind of wireless, wired, right, and the wireless, right, communication system, right? So this is become thing now like a Wi-Fi, right? And then also the IoT, this kind of wireless communication and 5G, right? So this become, I think, more and more common for the modern this kind of smart building and things. So that's something quite interesting. Of course, I see in the near future, where once you have a smart building, we now have IoT sensor. We also have what I guess in the near future we will have probably AI enable the smart building, so that actually Professor Ting Chen, our dean in the school of engineering, has a big AI chip center, so that actually we're trying to think about how we can incorporate this kind of AI for smart building. So that actually it should be concept. Yeah. Oh, one student. Sorry. I should try to upload this kind of lecture to our Canvas website. So I will try to upload this one. So anyway, so that I'll try to see. Anyway, so that so do you have any questions? So I think in general, building is no system engineering in general. I would say this is a thing. So that means it's not only try to look at the in terms of mechanical aspect, mechanical design, right, electrical design, and also you see this kind of ventilation system, electricity, and vibration is a quite complicated this kind of system engineering. That's why typical, right, in those kind of construction industry, they need to get a series of engineer, right? Not only civil engineer, but also mechanical engineering, building, engineering to think about every aspect. So I tell you, this is typical thing in Hong Kong. So that actually, so that typical this kind of a building engineer require this kind of different kind of engineering. So that I just upload. Sorry, the one student asked, okay, they cannot find this kind of lecture. I just upload this our lecture note on our Canvas website. Okay, if sorry, and then okay, so here I show you first for any kind of building, the first thing we need to think about in terms of design, like engineering design, is a structure. Right? Structural design, mechanical structural engineering, I mean mechanical design, right? So that you think about building, first you have a foundation, right? Foundation, and then you think about how to build this kind of a column and wall, beam, a girder and floor and roof. So these are all the mechanical structural member to make sure you can have a reliable, right, mechanical structure to support the loading, right, about now people inside the building, and also there's other support additional, maybe electric appliance and computer and many things, right? This kind of thing, this is a typical thing, right? So that the typical for in terms of mechanical loading on building, we have what do we have? We have typical, of course, Excel, right? All the mechanical structure has a they call the dead load. Dead load, all right. So that means actually many kind of building were built by either probably RC, reinforced concrete, or maybe other wood or something, right? And then you have dead load, right? And plus additional people. People is we call this kind of thing. Do you say? So live load and dead load. So these people actually is variable, right? And then that load are fixed. And of course, there's additional wind loading and raining and storm and like a typhoon in Hong Kong. Okay, so that load including this kind of architecture, construction, some equipment, mechanical, utility, sprinkler, and maybe computer, electric appliance, right? A light load including people, furnishing, machine, and wall, rain, snow, and ice. Okay, so that of course in Hong Kong we don't have, most likely we don't consider snow load, right? But in northern part of China, in North America, most likely also consider snow, right? So that of course in Hong Kong, wind loading I think it's important, especially every year we have a typhoon, right? So that especially 7 years ago, 2018 was super typhoon. So that wind loading, I think, is one of important thing. And another thing, earthquake. We are lucky in Hong Kong, and then most likely our foundation, right, is quite solid, in Hong Kong, so that most likely we don't have this kind of earthquake. But in some other places like Japan, Taiwan, and some in Southeast Asia, or in some maybe Sichuan in mainland China, so earthquake can be issue. So that so this kind of earthquake is important in selected area and region, right? And then we have a vibration load. For example, we have, if you have some the kind of subway of even high speed train station, and then so we consider about this kind of vibration load, right? And airport, and then of course shock load is another new like a topic, especially 911 in United States, in New York City, so that this shock load has been implemented in the building code in United States, right? So I think depends on the building code. It really depends on different countries. So that I tell you, this one is I think has been implemented in United States because due to the 911. So that, but of course, I think it really depends on the country region. So that at this moment, I don't think every building code in different country region will implement shock load. So that, but especially 911 create a big trouble. So that's why U.S. government, they do impose additional design requirement, so that those kind of structural engineer, when you design a new building, and then they have to do this kind of I think dynamic what's called structural dynamics analysis. I think this is, I just show you in more precise way. So the engineer not only has structural dynamics, okay, design, right? So that so in this case to study, right, this kind of shock load. Once you have some this kind of similar to 911 case, and then to study if this kind of design or building can survive this kind of under certain kind of shock load. So this is something I tell you is quite unfortunately this happened, and then this thing creates some big trouble. So that, and actually I do have some reference for this kind of thing, right? So after 911, so they do some researcher try to study why this kind of building in New York City will collapse. So it's a dynamic. Once you the airplane hit this kind of building, and do you know what's the reason why 911 happened? Huh? Any idea? It's very complicated dynamic problem, structural dynamics. Once the airplane hit the building, and then suddenly the gas and the oil spread to the building, and then cause a big fire. And then typical this kind of tall building, they have a stainless steel structure, right? And then once you have big fire, and then what happened? Huh? What happened? Big fire will if it reaches critical temperature, melting point, the steel will melt. So mechanical strength, right? Mechanical strength will become weakened. Mechanical strength, and then you create this kind of dynamic collapse phenomena. So unfortunately, this kind of 911 actually is some quite unfortunately. This is a real something very complicated, the structural dynamic problem. And then actually I can provide you this kind of simulation and study. Actually, I know that the U.S. government do this kind of investigation about why this kind of 911 this kind of happened. And unfortunately, more than 2,000 people died, right, in this 911. So that actually there's a series of reference thing, but I can give you some real real this kind of study and reference even some video about how this happened. It's a very complicated phenomena. Why? I would say it's a nonlinear this kind of the structural dynamics. Okay, so here now quickly introduce this kind of basic concept, right? So that when we design mechanical design, so that of course mention that we have to think about this kind of solid mechanics. Solid mechanics is one of fundamental UG course in our mechanical engineering, also in civil engineering, right? But of course, you may ask, what's different between civil and mechanical engineering? Typical civil engineering most kindly study those kind of mechanical structure. They will not move, right? Mechanical engineering most likely can design those mechanical structure, car, airplane, most likely can move, right? So that but from this kind of fundamental mechanics, solid mechanics actually it's the same. So that both, I would say both when UG we need study solid mechanics is one important like a core course in both ME and civil engineering. Okay, so that some mechanic will teach you how we can really think about mechanical design, right? Mechanical design is important for building and many other this kind of mechanical structure for car, airplane, and many things. Yeah, so that so when we think about this kind of structural member of the building, right? Basically, I was let me quickly show you why. So that I will show you in the first thing why a building is what? Building actually it can be we can decompose a building by what? Actually, we can think about building can consist of some key structure, maybe some this kind of a column. Most likely some most important structural member. Why? So this can be column, and then of course some of this one maybe has some relate to wall, right? So there's additional, there's one-dimensional structural member, and then this two-dimensional structural member, like a 2D play a wall, right? So this is our maybe wall, a 2D, two-dimensional. This is a column, right? So this column is 1D, one-dimensional structural member. So that we can try to look at this as a structural member, right? And then to think about once apply, there's a loading, right? As I showed you in previous slides, so that once a certain loading, and then how this kind of building's structural member will affect. Well, so basically you have some force, apply force, and create this kind of we call tensile stress. That basically is a stress, right? And then of course some structural member of building is compressive stress, okay? And then of course there's another one is shear stress. That means if I apply the loading, and then especially beam, most likely is related to the beam. It's a transverse loads, right? The loading force will apply not on this kind of actual loading, is a transverse, right? Direction. Transverse, okay, direction. So this is the actual loading force, okay? So that when actually in every building we do have this kind of like a column and the two-dimensional wall and this beam, right? So this is a very basic structural member for our building, right? So doing that, so that this is that's why we just show you this very simplified the way, right, to look at here, so that when we look at the mechanical design of the building, and then we have to study this kind of basic elements so that we can really do analysis, right? So that typically when we look at stress, this kind of stress, oh, sorry, I should also mention, so what's the meaning of this thing, right? So typically, most likely you will learn some maybe high school physics, right? Newton's law. Newton is F equals ma, right? Summation of the force equal mass multiplied by acceleration, or this is dynamic, using Newton's law. Why? If your static problem, that means all the force applied, summation over equals 0. So that so this typical thing we study, right? So that the summation of all the force, right, equals 0. So that's very one. So that this is static problem, and then so that we started the force, right? The I can be this many 2, 3, the many force apply on the structural member of the building. But then, so this type of thing we started in maybe high school physics, right? And but now if you want to look at this kind of mechanical design for the building or mechanical design for essentially, then what's stress? We ask this thing. Stress basically is a normalized force. Okay, so that is something is important. We just give you this basic concept, right? So that basically stress, I would say, is normalized force. Why we normalize force? With respect to this kind of the area of, most likely for this kind of thing, area of this kind of structural member, most likely this area will come from here. I'm out here. If you're here, then we look at those. Let me try here. So that's actually, we look at maybe use here. So basically, stress basically this is equal area. So the stress basically is a force divided by this area, maybe called A area. We normalize here. Why we want to do this one? Because for mechanical design, right, we need to look at the normalized force, and then because we need to think about those mechanical strengths. For example, mechanical strength is something normalized parameter, so that because every material with some kind of mechanical strength, right? Mechanical strength is normal, so that the stress actually is very important. So that when we study this mechanical design, our stress should be smaller than maximum allowable stress of every this kind of material we use for the building design, mechanical design. So this is one of the quite important concept why we try to think, right? Once you do this kind of normalized force, then you can really think about mechanical strength, right? And to what? To make sure that your mechanical design will not cause a kind of failure, right? If it's just too big, and then you may cause some damage about your mechanical structure, right? So it can make collapse, right? So that's something we don't want, right? If you have poor mechanical design and the building can collapse, then you can potentially can kill people, right? So unfortunately, we still happen. We do see some building a poor design, or maybe during the construction and some company they use the bad material, not according to the design, right? Structural design engineer, and then so that in this case, so that in case the stress may be too big and it cause some failure. So this is something unfortunately we still haven't. Of course, sometimes if building too old, then so that the mechanical strength of the thing may be too weak, and then it can collapse. That's why we need to really, this is one of the important issue we need to consider about the mechanical design issue, right? In terms of UG level of sound mechanics, right? So this is a quite basic concept. So in general, here I show you about this kind of typically, again, we have a compressed stress and also tensile stress. So that's typical thing, right? And also stress. One student asked the question, can the stress of two or more material be calculated by normalized force? One Jing Li, yes, okay. So that of course this kind of calculation require you to study a little bit more, right? Our course is only try to give you this kind of introduction to building engineering. So of course nowadays actually they do have some online this kind of online this kind of mechanical engineering, this kind of design tools, right? We call the mechanical CAD program. And all day we have to use those kind of things. we can use some UG level to use a hand calculation, or you can use like a typical those kind of CAD program, computer aided design, CAD program to work on this kind of study the stress and strain and then so that typically in our typical this kind of commercial, right? Commercial this kind of CAD program, right? CAD to do this kind of thing, like for example in mechanical engineering with ANSYS, right? Abacus, this is thing and I think there's a lot more for civil engineering design. There's also some special kind of commercial this kind of CAD tools, right, to study the kind of stress, right? So that of course nowadays actually you can find those online. Everything have many kind of cloud computing, so you can find those kind of online this kind of the CAD program now as sometimes it's free, so that I can share with you, right? So that even you are this kind of student, maybe you can look at those kind of online, this kind of cloud computing platform, right, to look things, so that I can provide you this kind of some select website. Even without this kind of understand very much more detail, you can look at those kind of free online CAD program, free online this kind of FVM software. You can try to see, you can look at things. So that now there's a series of this kind of thing. One actual software I actually ask UG student to try is same scale. Okay, let me show you this thing, so that now I see everybody you can accept the internet, right? So that this is actually same scale. It's a free online software. You can look at how they do this kind of design about mechanical structure, HVAC, and things like architecture and construction. So that actually now this online, this kind of cloud computing do provide you this kind of interesting way for new kind of engineering. Of course, one good thing here, this kind of online, this kind of computer platform, so that people can share about this kind of design. I encourage you, if you want to look here, so that actually you can register account and then sign up. Then you try to look at some people share about mechanical structure design, so that actually it's quite interesting to see. Right, in old day, we need to pay to buy commercial software, but actually, so this kind of online, the cloud computing platform, so that enable you to quickly try to find this kind of typical design of a building or some building engineering, see wind loading, thermal, mechanical, natural convection. So it's quite interesting. So that so on net zero building design, build BIM. So that is quite interesting. So that this kind of online free this kind of online, this kind of CAD tool become more common, and then so that you can easily try to look at this thing, right? So that in old day, you most likely very difficult for you to work on this kind of analysis about this kind of study, this kind of mechanical design, right? But now actually you can easily try to register account on this kind of selected open source, this kind of FEM, right? This is called the FEM, FEA or FEM, finite element analysis. Sometimes they call FEM, finite element method, to do this kind of structural engineering design or additional building engineering design, so that this become, I'll show you, very common now, right? So before, many of our engineers have to buy this kind of software, but you see that there's some interesting idea about open source. this kind of platform so that you you can easily register account and then try to look at this kind of thing. So that I say it's quite interesting. This kind of open source platform enable all of you to quickly try to get familiar with this kind of even building engineering design. So that I encourage you to try register account. At least same scale. I remember I do have some UG project as a student to try to start this kind of HVAC ventilation system for one of UG projects. It's quite interesting. So that so this is thing and it's free. So that it's quite interesting for you to think about how to use free. Use Google a lot so that actually you can also use it kind of free. Free is online the kind of build engineering tool for building engineering to look at those type of things, right? And of course, as I mentioned, so that beyond we study compressed stress and tensile stress, and also another issue is a buckling issue. If you have a very tall building, right, aspect ratio is much longer, and then you may create some we call instability into mechanical design issue. We call elastic instability. We call buckling. This is another phenomenon. I can show you this kind of video, then you can see about what's the idea of what happened. If you can have a good design, the stress is okay. Compared to tensile stress okay, but if you also look at this kind of issue of instability in terms of mechanical design. Let me show you this kind of buckling issue.
In order to test how much a column can withstand before it buckles, I will be using this contraption that I built. The slider will be what I will be placing the weight on to test the critical load of the material. The platform as well as the slider contain L brackets that allow me to test different end configurations. This is Euler's buckling formula, and it calculates the load of material will buckle under.
So this is another aspect why we study this kind of stress.
Inertia, which needs to be calculated.
No,
the K is the
stress in
factor,
all the
depends on the end configuration
member of such
and the L
building.
is the length of the
But
column.
if the length
When it comes to the moment of inertia, take into
aspect ratio is
consideration
different, then I
Then
skip
use
this
the change
analysis.
of
The critical
Therefore,
thing
you
is the
calculate
stress.
the critical
It's a
When it
critical
comes out
stress
smaller
issue.
than the given yield stress, the
And then this ratio will cause some buckling. You don't need to look at all complicated this kind of equation, but look at this experiment.
translation. For this test as well as
You see, if a certain loading, you see, this is what I show you, the buckling issue.
Once again used
You don't need to look at all the complicated mathematics, but try to look at this issue. If you have a good design, in terms of this kind of compressed stress.
In the next couple of tests, I will be using a fixed pin configuration. The pin configuration will only limit translation. In this test, I will be testing the critical.
Anyway, I just show you this give you some additional video to show about the issue of this kind of instability. Why it's a buckling. Buckling is another important mechanical design issue needs to consider, right? So that of course, as I show you, you may also use this kind of software, right? Online or this typical those kind of FEM software I show you, ANSYS or Abacus or something to start this kind of mechanical design. Okay, so that of course another aspect of this thing is related to this kind of file engineering. So that you know that even you have a good design, structural design, and then there's another issue. I think every building code have certain kind of fire engineering requirements, so that you need to think about how to use right material, have certain kind of fire resistance. Make sure that during the fire, and then you will not cause a big trouble, right, to kill people. So that of course another thing is we may every building, right, every office or classroom, we do have this kind of smoke detector, right, for fire engineering, so that also the sprinkler, right? So that this is another aspect, right? And then we also have flow system, so that and how we're going to have this kind of flow system. You can use steel or concrete deck or wood as a material, right? And then building wall, Actually, in reality, we have a little bit more sophisticated for typical building in Hong Kong or typical modern building engineering design, so that it's something you have to make sure you have fulfill mechanical design and also fulfill some maybe some issue related to the window, right? We lost the kind of transparency to let the this kind of solar radiation, solar lighting, right? Light engineering issue, right? So that of course we do have a typical tall building. In general, we have a steel frame design, and then of course steel frame is good, high strength, but there's some issue about fireproof issue, right? So that if a high this kind of temperature, it may cause a problem. That's why I show you this kind of interesting video as something about why this kind of simulation about this kind of 911. Let me quickly show you this video. Basically, so that once you have this kind of heating and you see dynamically structural dynamic collapse because mechanical strength become weakened due to this fire and melt, this stainless steel. So that's why this is one of quite unfortunately it's kind of a real sad story. Okay, I think we run out of time today, so that I don't know. Do you have any question? Any question for today's lecture? Okay, anyway, again, so that unfortunately now we are in the COVID-19 pandemic. So I do hope that you have to do this kind of even in this your apartment and your or maybe student hall, you still do some exercise, improve your health, and then do wear all the make sure you have good personal protection, social distance, and then so that make sure you keep healthy, and then so that to deal with this kind of difficult time in this kind of COVID-19 period. If any other question, and then maybe ask question on our campus website, so that I do encourage you ask question. That's it for today's lecture. Okay, bye bye.